Hello people, so this is my second video for the relation. See, I'm talking about most important types of relation. First one is reflexive relation. If every element of A is related to itself, like A comma A type of thing should be visible in R. Okay, so A related to A also this kind of thing you can see, or A comma A belongs to R. Then we will be able to say that R is a reflexive relation. Okay. For example, I am taking x comma y, so such that x is divisible by y. Okay. So I am checking for the reflexive one. Okay. So x is divisible by x. Can I say this one? Any number is divisible by itself. So x is related to x. So we can say R is reflexive in this case. Now let's check for the symmetric. Symmetric is a relation where A is related to B, and we can say that B is also related to A. The reverse is also true. Then this R will become a symmetric relation. Okay. And it is also written like if A comma B is present in R, I am searching for B comma A also in that R. For example, if L1 and L2 are there, okay, L1 is perpendicular to L2. L1 related to L2 such that L1 is perpendicular to L2. You can see the photo, there is a line L1 and another line is L2. Now L1 and L2 are perpendicular. So it is also said that L1 is perpendicular to L2, or I can also say that L2 is perpendicular to L1. It means I can say L1 is related to L2. This implies that L2 is also related to L1. So it is a symmetric relation. Now, if I go for a transitive means very simple that A should be related to B. If there is a condition like A is related to B, comma B is related to C, then this should imply that A should be related to C. This B and this B should be same. Okay, linkage should be there in between those two relations. So in this case, you will get it transitive. It is also written that A comma B belongs to R and B comma C belongs to R. Then we are searching for A comma C that is in R. And if these three things are present, we can say it is a transitive relation. For example, L1 and L2 relation is there L1 related to L2 such that L1 is parallel to L2. Now, if I draw a line L1 and that is parallel to the line L2, okay, and then I made a relation L2 related to L3. You can see here L2 related to L3, L1 related to L2. Okay, L2 is also parallel with line 3. So this implies that I can say L1 and L3 are related. L1 and L3 are also parallel, so L1 and L3 are also related. So this becomes our transitive relation. Equivalence relation is a relation which is reflexive also, transitive also, symmetric also. That kind of relation we call as equivalence relation. Example, you see one question I'm telling you. Check for reflexive, symmetric and transitive. A related to B such that A is brother of B. When this is there, I will check for reflexive. Now A related to A. What do you understand? A related to A means A is brother of A. What is this line? How can a person be brother of himself? So it is wrong statement. But if I go for the symmetric one, it is A related to B. It means A is brother of B. I don't know that B is a boy or a girl. Okay, but I know that if A is brother of B, it means A must be a boy. But if I reverse the line, B is brother of A. Now I don't know about the gender of B, so I cannot say it is B is brother or sister of A. So that is the reason this line is not correct. So even A is related to B, but I am not able to say that B is related to A. So it is not symmetric. But if I go for the transitive, A related to B, it means A is brother of B. Now I don't know the gender of B. A or B is a boy or a girl, right? But if I go for B related to C also, it means B is brother of C. It means B should be a boy, then only he can be a brother of C. But I don't know the gender of C now. C can be a boy or a girl, right? Now, if I have A related to B and B related to C, then I am checking for A related to C. Now, what will be the line? That A is brother of C. I don't know the gender of C, but still A is a boy that I know, so it is correct line that A is brother of C. So if this is true, then we can say it is transitive. Okay. So this is it. Thank you.